So at this point we're going to get more into switch configuration. Before it was just kind of generic iOS commands that'll work on all devices. Now we're going to get into more of the switch specific commands. And in order to follow along with that, you're going to either need a physical switch, packet tracer, or you have to kind of force GNS to give you some sort of switching capabilities. One thing I haven't mentioned up till now is that GNS is very cool, but it cannot emulate, it cannot run the actual switch CatOS for Catalyst switches. So what you have to do is basically add a router with a switch card in it, and unfortunately that's a little buggy and can kind of work sometimes and not work other times. I was testing it before this video actually, and with 3 different attempts I got 3 different results on whether or not line protocol would come up or down, or whether it would see that it was connected to something. It was driving me a little crazy. So going forward with the switching configuration, I'm going to be using packet tracer, so at least you can take a look at what packet tracer looks like if you'd like to take a class with Cisco and get access to that. And the commands are a little bit different as well, so that's also why I want to use packet tracer, because it'll use the actual commands that you would use on a physical switch, whereas in here with the switch module in a router, there's a few different commands you'd have to do to run, and I don't want to confuse people. So I'll show you how it works though in GNS, so that if you wish to do it this way you can. So you're going to go in and drop down a router. We're going to use either the 36 or 3700. Right click on that and go into configure, go to R2 and go to your slots. So here we can add and remove cards. So the wicks are for the wide area network serial connections for routers, and the other 2 slots are open. Then we can choose what we want. We can add some different types of cards and such, one of those being a 16-port Ethernet switch. So we can go ahead and add that in there and tell it okay, sounds good. We're going to start that up, and then we'll open the console. And now it's going to boot up. And as it boots up, it will, at one point it'll spew out a whole bunch of lines about the protocol being up and down and the switch ports going up and down. Once it's all done though, we'll be ready to configure. There we go, there's all our switch ports. State is down, state is up, state is down, yada yada yada. There we go. So now if we do show IP int brief, show IP interface brief, there's all of our ports. The first 2 are built in, and then the other 16 are that card. And here's something you can do you know how I've been configuring them, and I've been doing like 1/0 and 0/1 stuff. This is the card, and then this is the port number. So that's how that works. So this is a good example of it. Here is the built-in card, so that's card 0. This is with computers, numbers start at 0. And then that's port 0, port 1. And then we have another card, card 1, and that's that 16-port card we just added. And then here's port 0 through 15. So that's how that whole slash system works. And then if you had another card, it would be 2/0 through 15 and so on. If you were using stacked switches, that would also show up in this manner. So you would have potentially 3 slashes. So you would have stack member 0, 1, 2, 3, 4, slot 0, 1, 2, 3, 4, and then port 0, 1, 2, 3, 4 type look. So you'll sometimes see this, especially with serial cards. When we get into that, you'll see like serial controller 0, card 0, slot 0. So there'll be 3 slashes sometimes. So in here, if you want to try to configure this, if you want to get into the Vlan configuration side, once we get into Vlan configs, you have to go into Vlan Database on this. And normally you would think you would do that through configuration, config terminal, and then you would add your VLANs. Normally the commands would be something like VLAN and then the number, and then you can do some configurations from there. In this router though, to get into that switch card, we have to do Vlan Database. And now we're in Vlan config mode, and under specific Vlan commands we can run, such as let's make a VLAN and now I've made a VLAN. But a caveat of that is look at the name. Normally when you're configuring a switch, you would do something like VLAN 99, and then it would set you put you into config for that VLAN, and then you could say, okay, I want to name that, management or something. But you can't do that here. In order to do that here, you have to append it to the end of that one command. So you can see how it's a little bit different. So now, okay, now I've changed the name, and I've made the VLAN. So then if I exit out of this mode, it'll apply that. And actually, you know what, we'll go. And then if I show my VLANs, it'll show it in there. And normally you wouldn't have to go into Vlan Database and type show. You could just go back to the main exec mode, and you could say, show VLAN, and that would work. So there's some different commands here, and that's why I don't want to use this primarily. And then you could also go into a switch port here and apply the VLAN to it and such, as you would normally at least. But some of this stuff going into this Vlan database command can be funky. So what you could do though from here would be we could go into config mode, go into an interface on our card, and then we could say switch port access VLAN 99. So now it's a member of that switch port. And then I could back out of that, and I could make an interface for that, and I'll go through all this coming up in when I'm in Packet Tracer, but I just want to show you how this would work. We go in here, we could give it an IP address of some kind. I'm making an SVI here, and then we will back out. We'll new shut that, and we'll exit out of that, and we'll show interfaces. And now we have our VLAN 99, and that's up. It's got an IP address. And then I can add in some sort of host, and then I could configure this to connect from that port that I just configured over to this host. And then theoretically that would bring up the interface. So now here's where it's kind of funky. So sometimes this will work and it will say protocol up, sometimes it'll say protocol down, sometimes you have to manually tell it. It's kind of buggy from what I've seen. So that's also a caveat as to why I don't want to use this primarily. But I'm sure if you spend a few minutes browsing about on the GNS forums, you can figure out how to get that to work nicely. It could also be my iOS firmware version or something like that. So let's close out of this. And we're going to bring up Packet Tracer. So this is the simulator. It doesn't emulate, but it simulates. But it simulates very well. So let's go through some of the basics of a switch. So we've talked a little bit about the iOS and some of the basic things that are built into switches, but let's drop one here. If we go and look at it, it actually has this neat little thing. Let me see if I can zoom in for us. And it shows us what the switch actually looks like physically. So one of the things it has is a set of status LEDs across each of the ports, and sometimes the LEDs will be right next to the clip for the category for the RJ45 connection. You'll see like a little LED on each side of the clip. Sometimes it'll be above. You'll have two LEDs there. Sometimes it's one LED like you see on this one. Kind of depends on the manufacturer and the model that you have, and the colors will mean different things. So for each port, it would have a different color, and again, sometimes it depends on the manufacturer. For Cisco, the status LED will give you a link up or down status. So amber means it's blocked, green means it has a connection, no light means it's off. There's nothing plugged in, or something's not turned on the other side. You also have a duplex LED. So on this picture, they're not showing it, but if we had a second LED on above each port, it would then tell you, duplex and speed information. So green would be full duplex, off is half, For speed, it would be green is 100 megabits. Blinking green could be a gigabit. If it's off completely, it might be 10 meg. Sometimes it's also amber. It kind of make sure you check the user manual for your switch so you understand what the colors mean and whether it's blinking or not, if that's good or bad. And then we have sometimes a power over Ethernet light that might tell you if there's power being sent over that port. So green would be yes, off would be no. And then you have some standard system LEDs that'll be green for system power, amber for something wrong, stuff like that. If it's blinking, it might be in like a management mode or something like that. Remember I mentioned before you can recover your password. So the password recovery procedure is a little different for each model, although usually there's a basic procedure that kind of applies to all of them. So the basic method would be, now that we're looking at the physical device, you'd want to connect a PC to the console port, which will be on the back of this. And then we'll restart the switch, and usually on switches there are not, at least on basic switches like these, there's not a power off on. You just have to unplug it and plug it back in. So you restart the switch, and within 15 seconds press and hold the mode button, which is this, while the system LED is flashing green. So the system LED here. So as it's flashing green, hold the mode button. Continue to hold that mode button until the system LED turns amber, and then solid green. So it'll go from flashing green to amber and then to solid green. Once it goes to solid green, release that mode button. Then on the console on the PC, you should see it display switch at the prompt, and then from there you can go through you can delete your startup config, you can change the enable password, you can do things like that. And again, some of that depends on the model, so I won't go into specifics on that, but look it up online. You can just do Cisco, whatever model it is, password recovery, and they'll have the specific steps to do so. But that's the basic from a physical side, what you have to do to get it into the proper mode for a switch. So let's take a look at the boot procedure on this thing, and it just booted on us, so it comes up right when it gets dropped in there. We'll leave it on auto. Delete this, and I'll drop it in there, and then we'll just quick check out the command line. There we go. So what it's doing right now, it'll do a power on self-test. It'll load the bootloader from ROM, which it already did. It does it very quickly. It will start the CPU, so the processor will start up, and then it will start loading the iOS from flash after it initializes the flash. So it really does all those steps very quickly, like right there you saw it within a few seconds. So it'll do a power on self-test, it'll load the bootloader from the ROM, it'll start the processor, the CPU, it'll initialize the flash memory, remember that CF card, and then it will load the iOS file from flash and put it into RAM, and then that's what you're seeing here, and then it'll just start running that file once it gets loaded into RAM. So that's the boot procedure. It'll also at this point read the configuration file from NVRAM. Remember the non-volatile RAM, that's where our startup config is held. It'll read that and then apply that as it boots as well. So let's do a little configuration. We'll get rid of one of these because I don't need him. There we go. And you can see how this one puts us into user exec mode right off the bat, not privileged exec. So some things we can do. Let's do a show VLAN. Now this is a command you couldn't do on the other one in GNS because it doesn't have this exact operating system on it. On a regular switch you can do show VLAN, and that'll show you what ports are assigned to what VLANs. So all the VLANs you have configured will show up here, and then it'll say what ports are assigned to each. So that's a great printout you can take a look at to see what VLANs are assigned. And we'll get into VLANs going forward and what that actually means. But one thing to note here is VLAN 1 is your default VLAN, and that is assigned to all ports by default. It's also used by internal processing for certain services. So one thing that's recommended is that your management access to the switch be put onto a different VLAN, and you move your ports off of VLAN 1. When we get to VLANs, I'll probably reiterate this. But leave VLAN 1 turned on and leave it there just with nothing assigned to it, and it'll be used by the internal processing of the switch, but you won't have the security concern of having all of your ports on that default VLAN and having your management access on that default VLAN. So that's one thing to mention. To manage the switch, since I mentioned that, we have to create a switch virtual interface, and I did that on the GNS example real quick. And I said, here I am making an SVI, and boom, 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 done. What that is an interface IP for a specific VLAN. So the way this works is we have VLANs, which are virtual networks that are assigned to specific ports. And by default, a VLAN is a layer 2 item. It does not know anything about IP addresses. So you can divvy up your network into different networks that are overlaid onto each other, but it's layer 2, so you can have any sort of IP scheme on top of that in layer 3. In order to manage it, we need to give it an IP address on whatever VLAN that is, on whatever network we want to be able to access it from. We need to give it an actual IP address to connect to it through Telnet or SSH or something like that. So in order to do that, we need to create an interface VLAN, which is a little bit different from a VLAN. So a VLAN is a layer 2 item. An interface VLAN is a layer 3 item. It's an interface that we can actually configure with an IP address. So that's something we're going to do now. So let's go into enable mode, and we'll go into config. And notice here how I don't have to go into that Vlan database mode and things like that, so that's why I don't want to get into that. So this is the regular config you would do on a standard switch. You're going to go into config mode, and we're going to make a VLAN. So we'll make good old Vlan 99. Now that, and another difference, see how it now throws me into Vlan config mode? I don't have to append things to the end of this line. I can now, that I'm in Vlan config mode, I can say, oh, okay, now I want to name this management. So, looking familiar? Now I've named it management. I need to go pick an interface to assign to this VLAN. So we're going to go into interface. We'll do the first one, and we're going to say this port, this switch port, is going to be an access port on Vlan 99. And we'll get into access ports and trunk ports and what that means, but what you're saying is it's going to be used by end nodes to access it, and you're going to be a member of this VLAN, a member of this network. Now we're going to create, and that was all layer 2, so now we're going to create the interface to assign an IP address to it. So we're going to do interface, actually I'll just back out here so it's easier, interface Vlan 99. So kind of like when we did before where it was interface fasteth01 or something like that, we can say interface Vlan 99. And it says there we go, we've now made that interface, it's up, we're ready to configure it. So we're going to give that an IP address. So IP address 1.100 or something like that. We have to give it a subnet mask, so we'll use a /24 because that's just the standard a lot of us use. And then we have to turn it on. So remember the double negative, no shutdown. Now we've turned on that interface. If we do show IP interface brief, all the way at the bottom here, it'll show Vlan 99. So there it is, it's got its IP address. That's the interface VLAN, not this VLAN. Okay, that's the difference. See how it says in VLAN 99, here's the name of it, I gave it, this port is assigned. This is an interface like these that can be configured with an IP. It's two different things, don't get those confused. This is the SVI, the switch virtual interface. This is just a regular VLAN. So this we are going to connect to something to show it go up. Because if you notice here it says it's down right now. The line protocol is down, so there's nothing negotiating to it. So let's throw something out here. We'll add a computer. And then this little lightning bolt is your type of connections, and you can manually choose them, or you can tell it to automatically do stuff. I know I need a straight through, so I'm just going to say first interface, connect it to the computer. This is pretty cool here. This little orange amber is we'll get into this. It's called spanning tree protocol, and this ensures that there's no loops in our network. We'll get into that. And this, since this is simulating a real live environment, we actually have to wait the proper amount of seconds for this to go green. Something that GNS does not do with the lights. I was trying to see if it did that earlier. There we go. Boom. Now it came up. So now let's go take a look at our console again. And actually it just told us there it did in the console. If we do show IP interface brief, fast etho 1 is up because we have a computer connected to it, and the interface is up for the SVI. So now we can manage this. So let's do that. Let's remember I was configuring the line VTUI before for remote access. So let's do that again. Line VTUI 015, and I'm going to do password super secure Cisco, and we are going to do login local. If you do login and you do a question mark, so you can potentially use other methods of checking for login methods. You can use Radius or AAA or things like that. So you can define, I want to check the local database, or you can just say login and it'll just do the password authentication. But you can, if you do login local, you can also do usernames and passwords. So you have that option. If you do login, it'll do the password auth. If you do login local, it can check against the it'll check against your username database that might be locally defined. And if you do login AAA or something, you could then do a server-based authentication in a larger environment. So we'll get into that later, though. Just do login for now. So now we did login. That's been configured. We need to give this computer an IP address, though. So this is actually pretty neat. Like, here's our tower. Here's some physical things we can change on it. This is our actual desktop, like Windows or something like that. It's kind of neat. We can go in here to an interface, my fast ETH, and I need to give it some sort of valid IP address. The other one was 100, so we'll do that. There we go. So hopefully, and you can do some of the real basic commands in here as if it were a real computer. So let's see if we can telnet to my switch. Why did I just do 77? Oh, yeah. There we go. All right. So I type Cisco, and now I'm in my switch. So there we go. So I'm actually remotely connected to this switch through a virtual PC that's not real. So that's pretty cool. You can also do fun things like this. We can do a console connection. Remember I was talking about that blue rollover cable? We can connect my console to this guy, and then I can go into here and open a terminal, and that'll get me into the console through the console cable. So you can do some fun things like that. If you have access to Packet Tracer, spend some time playing with it, and you'll get used to some of these cool things you can do. So now we've added our SVI. We know it works. Some other things we can do is change the speed and duplex of different ports and such. So yeah, I need to set a password for that. That's fine. Do you notice when I was in here, I tried to type enable, and it doesn't let me do that from a remote access because I need to set a password for my enable. It won't let me jump into enable mode from a telnet connection right off the bat. So since we're here, let's go ahead and do that. So I'll do enable secret Cisco. There we go. So now let's go in here and change some port speeds. If I go into, we'll go into the interface we're connected on. So let's live dangerously today. We'll go into our first port. This is the port that we're connected to over telnet, actually. So this is the port that the PC is connected to. If we go in there, we have a couple different commands we can do. We can change our duplex settings. We can change our speed. So let's go ahead and do that. I want to make it half duplex. Normally it'll be set to auto. You can set it to full. You can set it to half. You can do whatever you want. And it didn't like that. So if we go in here, we'll have to set ours to half duplex too. And since we're there, let's also set our speed for that port to something different. So we'll set it to 10 megabits. So I'm going to show my running config, and I'm going to begin it with interface. Won't let me do that in here. It's okay. We'll show run. Alright, so there we have duplex half, speed 10. So now I can go back to my PC and get him connected again since I disconnected us. So I'm going to set it to 10, half duplex. Hopefully that'll negotiate. We got to wait for this thing to come up, hopefully. Alright, let's check this thing. Okay, there we go. So it was showing amber because we were on half duplex 10 meg instead of full. And there we go. Okay, good. So it was spanning tree. It was after all. So now I can get back in there, and now we're remotely connected again. So you can go in and change the speeds. Most of the time you don't have to. It's really unnecessary now in modern day. Everything can pretty much be left on auto. And in fact, with gigabit connections, you need to leave it on auto. Don't try to override it. It needs to be left on automatic so it can auto negotiate, and that's the way that it's supposed to work. Don't try and fiddle with it. One thing we can also do is set our MDIX. So remember I was talking about that whole crossover pair with the transmit and receive. So we can go in here and for an interface, see if it allows us in this one. No, this one won't let us do it, but some of the models you can say MDIX and then tell it, whether or not it's MDI or MDIX, and you can tell it to turn auto on or off. So that might be an option depending on the model you're using. You can tell it to do MDIX. Yeah, it wasn't here either. So it is interface based. So that's one to look out for. Usually on the newer devices with the newer firmwares, it'll have that turned on automatically, and that's really what you want to leave it on unless you have some sort of weird problem going on. So you've seen me do show IP interface brief, and I showed this earlier at one point for a second, but show interfaces becomes much more useful when you start talking about switching. because there's a lot of variables that can be set for each port. So if you type show interfaces, it'll give you all the detailed information for every single port, including things such as half duplex, 10 meg, is it set to something else? What's the encapsulation if it's, for some reason different? All sorts of things. Statistical information on it. Is it up? You'll hear people refer to it, oh yeah, that port's up. Well, that means administratively it's up, and then its line protocol's up, meaning it's connected to something and it's negotiated the connection correctly. So you'll see that it's up. Here's some other details about it. It'll give you some statistical information, as I mentioned, so packets in and out, errors, things like that. And it'll do that for every port, so you can just keep going down, and it's port after port. It'll give you that detailed information. But usually you don't need to look in it at that level of detail, so that's why show IP int brief is so commonly used, because we just want to know, is it up, or is it down, or is, what's the deal with it? And then a quick list of my ports, what IP addresses might be assigned, real basic things. So we'll stop here, and then we'll go into a little bit more with the switch security. We'll set up secure shell and talk about some type of attacks and stuff that can happen, and we'll go on from there.